Welcome to Study Loop.
Okay, so the question one is to determine the pressure and the temperature of air when the air velocity is equal to speed of sound. So when the air velocity is equal to speed of sound, the Mach number is equal to 1, which means that the critical properties will occur. So we have critical pressure and the critical temperature at a location. But first we need to determine the stagnation temperature and the stagnation pressure first. So for stagnation temperature, which is T0 here, is equal to T plus V squared over 2Cp. So we know the temperature is given at 420 Kelvin. We know the velocity is 110 meters per second. And the specific heat of the air at a constant pressure is 1.005 kilojoule per kilogram times Kelvin. So now we can plug in back to the equation to determine the stagnation temperature. Eventually, we'll have T0 is equal to 426.02 Kelvin. So now we can determine the critical temperature, which is the temperature at a location when the air velocity is equal to the speed of sound. So now let's plug in back to the equation to determine the critical temperature, which is equal to 2 times 426.02 Kelvin over K plus 1, which is 1.4 plus 1, since the specific heat ratio for the air is 1.4. And this will give us the critical temperature is about 355 Kelvin. So now let's determine the critical pressure. So first, let's determine the stagnation pressure. So I have stagnation pressure, which is P0 here, is equal to P times T0 over T to the power of K over K minus 1. So we have P, which is the static pressure, is equal to 0.5 megapascal, which is 500 kilopascal. And we know the stagnation temperature is 426.02 Kelvin, and the static temperature is 420 Kelvin. So specific heat ratio is 1.4. So if you plug in back to the equation, eventually you have the stagnation pressure is equal to 525.5 kilopascal. So now let's determine the critical pressure, which is the pressure at this location. So this is equal to 525.5 kilopascal, and then times 2 over 1.4 plus 1 to the power of 1.4 over 1.4 minus 1. And this will give us the critical pressure, or the pressure at this location, is about 278 kilopascal. So now let's determine the ratio of the area at this location to the entrance area. But first, let's determine the ratio of the entrance area to the area of this location. So if A over A asterisk is equal to 1 over MA times 2 over K plus 1 times 1 plus K minus 1 over 2 times MA squared to the power of K plus 1 over 2 times K minus 1. So first, let's determine the Mach number. So when the Mach number can be equal to air velocity over speed of sound. If we plug in the values, eventually we'll have the Mach number is about 0.268. So now let's plug in back to the equation to determine the ratio of the entrance area to the area at its location, which is equal to 1 over 0.268 times 2 over 1.4 plus 1, and then times 1 plus 1.4 minus 1 divided by 2, and then times MA squared, which is 0.268 squared, and the whole thing here to the power of 1.4 plus 1 over 2 times 1.4 minus 1. And this will give us the ratio is about 2.254. So now we can determine the ratio of the area at this location, which is the critical area, to the entrance area. which is the reciprocal of such value. So we have a asterisk over a is equal to 1 over 2.254, and this is equal to 0.444, and these are the answers for this question.